When a fire suddenly breaks out, the human brain tends to fixate entirely on the chaotic, visible flames. This natural reaction often leads to panic, causing people to deploy equipment randomly rather than strategically. This diagram isolates the fire triangle at the base, where heat, fuel, and oxygen interact. The fuel's chemical makeup varies by material, classified into distinct threats: Class A for wood, Class B for flammable liquids, and Class C for electrical fires. To counter these chemical threats, we rely on the standard red ABC dry powder fire extinguisher. It carries a payload engineered to neutralize multiple reaction types simultaneously. However, an engineered payload only works if it reaches the fuel source. Survival requires mastering the physical mechanics to deploy that payload, which is why we use the pass method. In its resting state, an extinguisher is a dormant, pressurized storage canister. Every component is secured to hold back the force of the internal gas. The first mechanical step of pass is pull. By firmly pulling the safety pin at the handle, you snap the tamper seal. This cross-section of the valve assembly shows the result of that action. The pin blocks the lever mechanism. Once it slides away, the unit is armed for active use. The second step is aim. Maintain a safe distance from the heat while directing the hose towards the base of the fire. The stream must be directed downward to reach the fuel source, where the reaction occurs. Aiming at the tall flames leaves the fuel untouched. Trajectory physics are vital here. Hitting the base at a downward angle ensures the high-velocity powder penetrates the reaction zone, preventing the discharge from blowing burning fuel across the room. The pull and aim steps establish your mechanical preparation. They ensure the chemical countermeasure strikes the actual site of the fire, rather than being wasted on the upper flames. With the unit armed and aimed, the operator engages the discharge lever to initiate deployment. This is the third step: squeeze. Compress the lever slowly and evenly. Abruptly jerking the handle can disrupt the internal flow. This cross-section illustrates internal fluid dynamics. Steady compression opens the valve, allowing pressurized gas to push dry powder up the central siphon tube. Consistent pressure creates a predictable flow, preventing the unit from expelling its payload in one rapid burst. The final step is sweep. Move the nozzle in a side-to-side motion to ensure the dry powder covers the entire width of the burning base. The sweeping action drives the smothering process. By blanketing the fuel source in powder, you create a physical barrier that starves the reaction of oxygen. Even after the flames disappear, the fuel remains hot enough to restart the oxidation process. Watching for reignition is critical, as a break in the powder barrier can allow the fire to return. By combining steady fluid dynamics with wide coverage, the squeeze and sweep actions physically dismantle the fire triangle. Proper deployment of a chemical countermeasure reverses the chaos of an emergency, allowing an operator to exert environmental control over the hazard. Pass provides a mechanical sequence for managing discharge pressure and trajectory during an emergency. Mastering this sequence equips a bystander with the specific physical mechanics needed to dismantle a hazardous chemical reaction safely. Safety depends on understanding how these tools function. When you understand the physics of the equipment, you can replace a panicked reaction with calculated action. Learning the internal science of the ABC extinguisher and the mechanics of pass allows you to control an emergency as it happens. Practice safety every day and stay safe out there.